we're going to have a quick session here about how to run an RMG job. And then Richard is going to take over again and tell us about molecular representation in RMG, which is pretty core to the way that the entire system works. So stick around to see that one. So I believe I finally got Docker working on my machine, so that's what I get for trying to do a live tech demo. But we're going to try now to actually run an RMG job. So I have the command here for running RMG, and I'll zoom in a little so that it's easier to read. But again, this is just taken from the RMG. Oh yeah, that's like, sorry, that's impossible to see.
On Zoom, they can see it though.
It works on Zoom. Okay, sorry, in-person people.
Slightly above 100%.
Bad projection. Yeah, so anyway, this is the command copied from the documentation. I'm going to slightly change the name so that I can run it again. Oh no, we lost Marcus. The documentation command is this docker run RMG container here.
Okay, and you ran that one, Marcus.
Oh, yeah, so you should. Yeah. Right, so everyone is hopefully seeing something that looks roughly like this. So you should see RMG underscore environment all the way to the left. That indicates that we're within what's called a conda environment. It's basically a sub-isolated set of programs and code that's specific to RMG within this container. Root is just the name of your user inside the container. So you have sudo privileges when you're sitting inside the container if that matters to you. Don't worry about this little tag here. And then this is your current path. So this container, and actually, sorry, before I start explaining, what everyone can do, run this command, python rmg.py help. This is going to take a while to run if you're on RMG 3.2.0. If you chose to use the latest version, it will probably be faster. The difference is that RMG 3.2 has the mandatory inclusion of reaction mechanism simulator, which takes a long time to start, but then is quite fast once it gets going. And hopefully, this very, very slow run should only happen once when you run this command. So in the future, when you're trying to generate mechanisms, it won't be as slow. But so while this is running, a quick explanation of what we're doing. So inside this container, you're on a Linux operating system. So it's slightly different from Windows and more similar to Mac if you're starting from there. But it's a shell sort of similar to the command line in PowerShell or command shell like in Windows. So again, back to the documentation, we are aware that this can be a little bit of a jump if you've never used the command line before. So we have suggested tutorials here about using Bash and using Linux, which are the shell that we're in and the op using respectively. Again, I'll reiterate that we are very fortunate to be in the era of large language models, which are super helpful for this kind of thing. So if you want to know a command to find this file that I edited 3 days ago, you can ask ChatGPT and it'll come up with one that probably works. But in general, it's similar to what you've seen before. So the mechanics of this actual command that we're typing in, Python, first and foremost, is the programming language that RMG is written in. So when you write Python, it opens the Python program, which you can think of as any other program on your computer. It's like Word or Excel. It's just that someone else wrote some code, and it happens to be that Python's job is to execute other code that we wrote. That code is right here in rmg.py. That is a text file of code that actually has instructions for how to do all of the magnificent features that we've told you about so far today. in terms of generating mechanisms and making thermochemistry estimates and so on and so forth. This help command is just something to test that your installation is working, --help. And then all of the more complicated commands that you would think of running and actually passing in input files to generate interesting mechanisms, again, we'll circle back to the documentation. So this is our fault. We should have it underneath the normal installation instructions. But if you go to installation from source and then scroll down to step 11, this gives you your first example of the general mechanics of running RMG. So again, we have our Python, we have our rmg.py, and then input.py.
This is where there's a divergence whether you install 3.2.0 or the latest.
Yeah,
Right?
yeah. So within the
Sorry, where were you on?
it's so if you are starting from the installation instructions, you scroll down to installation by source using Anaconda environment. And then at the bottom, step 11 is an instruction for running a basic command. And you'll notice it's generating a bunch of output. Behind the scenes, what that's actually doing is, and this is answering the question from Antonio in the chat, RMG version 3.2.0 uses Julia, mandatory, not optional. And on the very first run of RMG, not necessarily a mechanism generation, but even a basic case where we're just running help, Julia, behind the scenes, is compiling some additional stuff specific to RMS. So if you actually read the code here, you can see that we're in Reaction Mechanism Simulator, and we're compiling domain.jl, which these warnings are just something from Julia saying that it doesn't quite like the way that we've prepared that code, but you can ignore them on the first pass. For those of you running the latest version, those should be absent. The latest version of RMG, which we're hoping to call RMG 3.3 shortly, no longer requires that you have Julia installed or available. And if you do have it installed and available, but you don't use it, it should just skip the process of running all of those extra compiles and things. So this container that I've just opened is running the latest version of RMG. So again, I can run Python rmg.py. And then this is the command that I'll leave you with before we go to Richard to learn a little bit more about RMG behind the scenes. And I encourage you to analyze all the output that it generates and things like that. But you're going to start the command with Python rmg.py. And then what I'm doing is pressing tab. This is something for Bash, which is very nice. It'll show you all of the files that are in your current directory. So what you'll want to notice is we have an examples folder. So the examples folder is what it sounds like. It's some common examples of things that you might want to run with RMG. So we're going to do examples, RMG, pressing tab again. And you can see that we have a ton of coverage here of things of interest. So some of these might be able to be immediately adapted to the case that you care about. If you're doing halogens, for example, check out the halogens example. What we'll start with right now, just because it runs really quickly, is super minimal, which is what it sounds like. It just runs a very basic RMG setup. You can see in this folder we have some demo notebooks, which the Jupyter Notebook instructions that we have in the documentation will allow you to run those. But to actually do the mechanism generation, you're going to do Python rmg.py and then just the path to the input file. The path here just indicates how to get to input.py. Press enter, and then it will actually go through and generate the mechanism according to whatever instructions that you have. So that will run in the background. The previous one is still running, so you can see why we maybe shifted away from having Julia be absolutely required. But
The latest, that Docker image does have Julia and RMS, so it's
Still there, right? It's not like you're running without
Julia
Julia to demonstrate it's not faster.
Yeah.
We've made it how it's.
yes, yes. So you can still do everything in the latest version that you can do in the previous version. But again, come to the 4:30 session if you want to learn how to install for developer applications, and we'll show you how to circumvent having Julia at all if you want. So the last thing I'll say for now, before we move to Richard, which I think is
You still have some time.
okay. Again, looking at the documentation for RMG, you can see the user's guide, which this will have, again, links to the installation instructions, which we've been going over so far, as well as the input files, and then the example input files, which are what we're running now. So here's one for ethane pyrolysis, and we're going to have entire sessions coming up dedicated to how to actually read and write these files. But what we're actually running in the Docker container right now is something that looks like this. So we specify the database that we want to use. We specify the species, the reactor. You can see all the things that Richard was mentioning this morning, things like the temperature, pressure, initial mole fractions, termination conversion when we want to stop, or alternatively the time, the simulation tolerances, which are of course important to tune, and then some miscellaneous options. But yeah, that is everything to get you just up and running something with RMG. So again, you can still see that that's doing Julia things in the background, but eventually that will finish. Again, that should only be required to go once and then should be quick from then on out. And I'll plug one last time. We're going to go through the developer installation instructions in slightly more detail and how to do GitHub mechanics and make contributions to RMG at the session at the end of the day. So come to that if you're curious about that too.